my god, I'm gonna fail math. I don't know how to solve this problem. Mitch? Where are you? Oh, okay. I'll be there in 1 minute. Mateo, no sé.
So you need to move this. So the period. And then you have to write. Oh, it's Emiliano. Hello? Yes, we're in cubicle number 7. Yeah. Okay. Bye.
Hey, I really need some help with this problem. It's very difficult.
Oh yes, we'll explain it to you.
Emiliano's problem may seem to be very difficult, but actually it's very easy. But it has so many parts to answer it, and we're going to explain it.
Well, the problem is, in a predator-prey model, the population is modeled by the function y is equal to 900 cos to t plus 8,000, where t is measured in years. The first question is, what is the maximum population? Sketch a graph of y and find the length of time between successive periods of maximum population. How are we going to solve the first question?
I know who to call.
Hey.
You need help with that problem?
Yes,
Yeah,
please.
Of course.
So, A is for amplitude. K, you will need it to take your period. And B is your horizontal shift.
But since we're talking about a population, 900 would be individuals, so the unit we would use is like a person or an individual, an animal in this case.
Okay, I think I'm starting to understand, but I still don't know what amplitude is for, the period, and horizontal and vertical shift. So, can you start from the beginning, please?
Since you don't understand anything, we're going to explain you what simple harmonics are, because this is a problem from simple harmonics and it is going to explain it to you.
So to start, I first need to define what a simple harmonic motion is. It is usually represented by a spring mass system, which is basically a spring with a mass at the end. It is worth noting that this happens in a theoretical environment because there is no friction or resistance and there is no loss of energy. So if you would pull the string, then it would bounce back and then it would be like compressed, and then it will return again to the extended period. And this would repeat itself over and over again because there is no friction and all. So if you were to graph this motion, you would get a graph which would look like a wave, because there is a point of maximum, a medium where it is on its normal state, and a lower state which is compressed.
The y-axis in this case represents the number of animals, and the x-axis represents usually the time. And the elements of the graph. Here you can find the amplitude, which in this case you can get the range of the graph and also the maximum and the lowest points. Question C is actually asking for the period as the distance between crest, this one, to this one, and is the period. It is measured in years in this case.
Now, going back to the Springman system, we also have another measure, which is the frequency and is measured in hertz, as it produces sound and refers to the vibration of the spring. It is represented by an F and is calculated with this formula. F is equal to 1 over period. In the graph, it means how many waves are produced in a given interval.
Oh, okay, so I think I'm getting it now. Can we apply it to the first problem?
So now, if we want to start comprehending this problem, we simply need to compare these two formulas, which are very, very similar. This is a cosine graph. So, if we take this one, we know that 900 is our A, which is our amplitude, which is how much the graph is going to go up, and it's how much is going to go down from its starting point. In here, we have to compare it to this one. We need to obtain our K, since in here we don't have anything. But we simply need to factorize. You need to have a cosine of 2, and you will simply leave t within the parentheses. And the 8,000 is c, which means that it will have a huge horizontal shift. Therefore, our graph is going to start on 8,000, and it's going to go up all the way to 8,900, and it's going to go down to 7,100.
Oh, so that's how you do it. It was actually very easy.
Now, to actually start the graph of the problem, we first need to get our period. You get it by using this formula. T, which is period, equals 2 pi over k. And since I previously said the k in our problem is 2, we simply substitute. So t equals 2 pi over 2. So now you eliminate, and therefore our period is pi. So because our period is pi, it means that our whole graph, or a period of the graph, will fit within this line. So we have it here, and since we have a horizontal shift, we also need to make a line.
To start solving the problem sketching the graph, first is easier as it gives us a visual aid. But first, we should understand what the graph means. As said before, the y-axis represents the population of predators, and the x-axis represents time. So we need to get our time periods. Let's remember that to calculate the spaces, we simply divide our period by 4. Since our period is 5, we get these separations. Now we're going to take the amplitude. As you remember, the amplitude in the equation is A. Here it is represented by a 900. So from this line, you're going 900 down and 900 up. As you remember, the graph of cosine, when it is positive, it has this shape.
So the first point is going to be here. The next one will go here. This is the maximum point. The lowest point will go on pi over 2. Then again, you go up here. And the last one will go on pi. Now it's going to be like this.
And don't forget to mark the lines like this.
Well, based on the highest points of the graph, which are these ones, this will be the maximum population, which is 8,900 predators. This will be the maximum population.
So for question C, you have to find the length of time between successive periods of maximum population. So just remember that your x-axis is the time. So you just need to check how much time is from the beginning of your graph to the end, and it is pi. So the answer for letter C is.
So I get it now, but what other type of applications does this problem have?
Well, if you can remember, we were talking about the springs. Well, the shock absorbers in a car that make up the suspension, by comprehending the properties of the spring, can make a ride be as smooth, as sharp as you want.
Yeah.
You need question.
The JX... Why you
Sigue, sigue, sigue.
No, otra vez, ese es un blooper.
The Y-axis.
¿Lista?
Ya. Ya,
Okay.
ya.
Ya.
Okay. So now, sí.
Otra vez.
Now
A ver, espera, entonces.